Thanks for watching my video today. Let's evaluate the parser fraction expansion of secant x. Okay, secant x. Then is secant x. Then is sec x is equal to 4 pi. Sum from n equal to 0 to infinity minus 1 to then 2n plus 1 upon pi square 2n plus 1 square minus 4x square. For or minus 1 over 2 plus x over pi is not belonging to integer. Okay. Now we are going to use again integration. Okay, integration to prove this expansion of secant x. So we know that in the previous integral from 0 to infinity x to the s minus 1 upon 1 plus x dx is nothing but pi over sine pi s, which is gamma s gamma 1 minus s. Always know that in order to get sec, so I'm going to prove 1 over cos x. Okay, we know that 1 over cos x is nothing but sec x. Okay, so in order to get this cos, draw here. Okay, sine. So if you want to get cos, what are we going to do? This one. So sine pi s is same as cos pi by 2 minus pi s, right? So it is just the same thing, meaning cos of pi 1 by 2 minus s. Okay, so meaning if you substitute s equal to something like this, then you get, right? But here I'm using plus. Okay, plus also just the same thing, plus sine 90. Okay, same thing. So sine 90 plus 1 some angle is cos, right? That's the same thing. Therefore, so if you substitute s equal to 1 by 2 plus s, and we have already evaluated in the previous gamma of 1 by 2 plus s, gamma 1 by 2 minus s is pi over cos pi s. This is what we are going to do now, meaning this is derived from this one. Okay, these two. If you put s equal to 1 by 2 plus s here, then you come out with this one. Okay, meaning this, since this or gamma is same as this one, so if you put s equal to 1 by 2 plus s here, then you get this one, right? Therefore, or I, let me call or I to be integral from 0 to infinity x to the s is 1 by 2 plus s. Okay, 1 by 2 plus s minus 1 upon 1 plus x dx, which is integral from 0 to infinity x to the, simplify it, s minus half upon 1 plus x dx. Okay, now again using the property of definite integral from a to b is same as a to c into plus c to b. Okay, so 0 to infinity is same as 0 to 1 x to the s minus half upon 1 plus x dx, plus integral from 1 to infinity x to the s minus half upon 1 plus x dx. Now this one I'm going to keep it as in its, it will be remain as in its, and this one I'm going to use substitution method. Then is put x equal to 1 over x. Okay, implies dx is negative 1 over x square dx. Okay, then in the second integral, this one, so I is equal to first integral is s in is plus, so if you plug here x equal to 1, so this x will be 1. If you plug here infinity, then this x will be just 0. Okay, and in place of x, 1 over x to the s minus half upon 1 plus 1 over x, and dx is nothing but negative 1 over x squared dx. Again, we know that integral from a to b is same as negative integral from b to a. Okay, so because of this negative, we can change this lower and upper limit. Okay, then I is equal to integral from 0 to 1 x to the s minus half upon 1 plus x dx, remain the same thing, plus integral from 0 to 1, so this one is same as what, x to the 1 by 2. Okay, 1 by 2 minus s upon 1 plus x upon x into 1 over x squared dx. Okay, this is I is equal to integral from 0 to 1 x to the s minus half upon 1 plus x dx, plus integral from 0 to 1, so x to the this x and this 1x will be cancelled out, and this still remain x, okay? So this x will be coming out here, then you get half minus s, then this half minus s because of this one, so it will be negative 1 upon 1 plus x dx, okay? So I is nothing but integral from 0 to 1 x to the s minus half upon 1 plus x dx plus integral from 0 to 1. Simplify this, x to the negative s, negative half, okay, upon 1 plus x dx. Now we are going to use the geometric progression. We know that 1 over 1 minus x is nothing but sum from unequal 0 to infinity x to the n, which is implies that, so I'm trying to find out this 1 plus x, okay? 1 over 1 plus x is nothing but 1 over 1 minus negative x, okay, which is it will be sum from unequal 0 to infinity negative 1 to the n, okay? According to this, if you put here x equal to negative x, so you get negative x to the n, and this one simplify in this sum from unequal to 0 to infinity minus 1 to the n into x to the n, okay? Now here is the second part. Now I'm going to replace 1 over 1 plus x, these two, in terms of this summation, okay? This sum, then what do you get? Okay, wait here. I is equal to sum from unequal to 0 to infinity minus 1 to the n, so interchanging sum and integral, okay? Integral from 0 to 1 x to the s minus half, this one, into x to the n, right? This one, x to the n dx plus sum from unequal to 0 to infinity minus 1 to the n, integral from 0 to 1 x to the negative s, negative half, into x to the n, this one, x to the n dx, okay? So I is nothing but sum from unequal to 0 to infinity minus 1 to the n, integral from 0 to 1, so combine these two, x to the n plus s minus half, right, dx plus sum from unequal to 0 to infinity minus 1 to the n, integral from 0 to 1 x to the n minus s minus half dx. So integrate it, I equal to sum from unequal to 0 to infinity minus 1 to the n x to the n plus s minus 1 by 2 plus 1, right? Because integration of x to the n is x to the n plus 1 upon n plus 1, okay, using that one. So this one upon n plus s minus 1 by 2 plus 1 from 0 to 1 plus sum from unequal to 0 to infinity minus 1 to the n x to the n minus s minus half plus 1 upon n minus s minus half plus 1 from 0 to 1. Now if you plug 1, so 1 to the this power is just 1, okay? If it is 0, so this will be 0, so you will get sum from unequal to 0 to infinity minus 1 to the n 1 upon, so n plus s, so minus half plus 1 is plus half, okay? Plus half plus sum from unequal to 0 to infinity minus 1 to the n, plug 1 here, 1 to the power, 1 to the any power is just 1, and 0 is just 0, so it will be n minus s, so minus 1 plus 1 is nothing but plus 1 by 2, okay, plus half. So now this sum and this sum common, so I is equal to sum from unequal to 0 to infinity minus 1 to the n 1 over n plus s plus half plus 1 over n minus s plus half, which is sum from unequal to 0 to infinity minus 1 to the n. Now combining them, you get this one, n minus s plus half, this one, plus this one, and this n plus s plus half, okay, upon n plus s plus half into n minus s plus half. You can get cancel s, okay? Then sum from unequal to 0 to infinity minus 1 to the n, so n into n plus n is nothing but 2n plus half is nothing but 1, okay, upon, now using this a, okay, this and this one, okay, n plus 1 by 2 plus s, n plus 1 by 2 minus s is nothing but, okay, now we change it, n plus half plus s, n plus half minus s, okay, which is sum from unequal to 0 to infinity minus 1 to the n to n plus 1 upon n plus half whole square minus s square, right? And using this one, a square minus b square, a minus b, a plus b, okay? Using that, you get that. Now simplify this, you get I is equal to this one, so it will be I is equal to sum from 1 equal to 0 to infinity minus 1 to the 2n plus 1 upon. So substitute here. So here if you simplify this, so 2n, right? 2n plus 1 whole square minus 2 square means 4, so it will be coming here 4s square, and that 4 again will be coming out here in the numerator, then is 4 here. Okay, 4s square. Then is one is our original one. Our original one is this one. So integration of this one, okay, the meaning this is nothing but pi over cos pi s, right? So our integral I is nothing but pi over cos pi s. Therefore here our integral I is nothing but pi over cos pi s, which is 4 times sum from 1 equal to 0 to infinity minus 1 to the 2n plus 1 upon 2n plus 1 whole square minus 4s square, okay, 4s square. So this is another this is the expansion form pi over cos pi s. Now so in order to get this sec, okay, in order to get sec, meaning we know that this one sec x is nothing but 1 over cos x. So I'm trying to get this, I'm trying to get right of this pi, okay, this pi. So putting s equal to x over pi, we have pi over cos pi into x over pi, right? Such that these two will get cancelled, right? It's equal to 4 times sum from 1 equal to 0 to infinity minus 1 to the 2n plus 1 upon 2n plus 1 whole square minus 4 into, here is 4 into s is nothing but x over pi whole square, right? So what do you get? So you get pi over, cancel out, so cos x is equal to 4 pi square. So this pi square will become here 4 pi square sum from 1 equal to 0 to infinity minus 1 to the 2n plus 1 upon this pi square will be coming here again. So pi square 2n plus 1 whole square minus x square into 4, okay, x square into 4. Therefore this pi and here 1 pi will get cancelled, right? So 1 over cos x is 4 pi sum from 1 equal to 0 to infinity minus 1 to the 2n plus 1 upon pi square 2n plus 1 whole square minus x square into 4. We know that secant x is 1 over cos x, so this is nothing but secant x is 4 pi sum from 1 equal to 0 to infinity minus 1 to the 2n plus 1 upon pi square 2n plus 1 whole square minus 4x square. This is what we are exactly trying to find out, okay? So this one is same as this one, right? And this one pi over cos pi s, so 1 over cos pi s, 1 over cos pi s is nothing but sec pi s, okay? So just this one is same as pi sec pi x is nothing but 4 times sum from 1 equal to 0 to infinity minus 1 to then 2n plus 1 upon 2n plus 1 whole square minus 4x square. In place of s equal to x, okay, then you will get this. So this is how I managed to prove the partial fraction expansion of secant x, okay? That's it.